Let's review the difference between physical and logical replication. As you can see here in this diagram, I have 3 database instances, one for the main server and 2 for the replica servers. The replica servers will only copy data from the main server. They will serve as read database, and the main server can serve as read and write database. When we use physical replication, all the server instance is copied. That means that it will copy all the databases with all the tables. With Postgres Logical Replication, it's possible to cherry-pick what you want to copy, thanks to a feature named Publishers and Subscribers. Publishers should be created on the main server, and subscribers to these publishers can be created on the replica servers. Also, when we create a new publisher, we can choose what tables should this publisher listen to. That means that you can configure a publisher to listen to an entire database or just specific tables. You can also create as many publishers as you want. After you created the publisher, you can create as many subscribers as you want. We should be aware that if we want to create a subscriber to a publisher, the database schemas and tables should be equal. That means that before creating a subscriber, we need to create the database and the tables on the replica servers. After that, you can create the subscriber and all data will be copied. Now, let's go to our example. In this project, I'll create a movies database that has 2 tables, authors and movies. Authors has an ID and name. Movies has an ID, a name, and author's ID. For the database servers, I will have only 2. One for the main database, where I can write and read data, and another for the replica database, where you should only read data from. This kind of setup could be very useful for scenarios like this one here, where we have our main app that can read from the main database and from the replica database. But also, I have another apps like analytics or reports that only reads from the replica database, so they can run heavy queries without affecting the main app performance. In this example, I'm using Docker Compose to run 2 Postgres instances. I'm using only a Postgres vanilla image, as you can see here. I also have a SQL script to create the tables authors and movies. And I have another SQL file to populate data, where I insert 3 authors, Joe, Maria and Lisa, and 3 movies, movie 1, movie 2 and movie 3. We can run our Postgres services with Docker Compose app. After running our services, let's create the databases using this script here. I will execute a create database command on the main services and also on the replica service. After creating the database, we can create the tables with this command here. Remember that we need to create the tables on both databases, the main database and the replica database. After creating the tables, we can populate the main database and only the main database with the data. In order to populate the main database, let's execute this script here. Now, let's check if the main database has the new rows. We can do that by doing a select from authors and movies. And as we can see here, the main database has all the rows. And of course, if I execute the script on the replica database, it is still empty. Now, with all the database and tables created and the main database with data populated, let's create the publication. With this command here, we can do that by execute a create publication command on the main app database, where I give it a name and I tell that it should listen to change on all tables. Now let's execute the script in the terminal. We see a warning here. Wall level is insufficient to publish logical changes. In order to fix that, we need to stop our services and change our Docker Compose file. We need to enable an option for the main Postgres service to change the wall level to logical. Wall means write, ahead, log. It protects our database from failures and ensures data consistency by saving all the changes to a log file before the changes are applied to the database. That means, in case of a failure, the database can recover by reading this log. In our example, we need to change the wall level to logical on the main service database. With that in mind, after changing this option, the publishers should be working fine. Let's start our services with Docker Compose up, and everything should be working fine. We don't need to create the publication again. If you try to do that, it will say that the publication already exists. Also, if you try to create another publication with another name, it should create with no problem. Now it's time to create the subscriptions. Before doing that, let's just check the replica database with a select. There are still no rows. In order to create a subscription, we can execute this command create subscription. We should give it a name, the host it should connect to, the database name that it should replicate, and also the user and password that are from Docker. And don't forget to specify the publication name that you will want to subscribe to. Let's run it in your terminal. Yay! The subscription has been created. Let's verify it by running a select in the replica database. And as you can see here, all the data has been replicated to the replica database. Now let's test it with new data. I will insert 2 new authors, Pedro and José, and one new movie, movie 4. Let's execute the insert on the main database, and after inserting the new data on the main database, let's see if it was replicated on the replica database. We can do that by doing a select. And as you can see here, the data was replicated. But be aware that it has some limitations. Database schemas and tables must be identical. Also, it doesn't replicate index or sequence, and large objects are not replicated. If you want to know more how to handle table changes, I'll leave a link in the description. See you later.